Hello everyone, my name is Jun. I'm a PhD student from University of Maryland, College Park. In this work, we present a tag, Boosting Test VQA will test-aware visual question-answer generation. It is the first genetic test-aware question-answer generation approach for the task of test-related VQA. This is a joint work with Salesforce Research. The co-authors are Minfei, Yu Qian, Ram, Chetan, Ran, Joseph, and Larry. Here we address the task of test VQA. Test VQA is a fine-grained direction of the VQA task, which only focuses on the question that requires to read the texture contained shown in the input image. For example, on the top image, the test VQA model needs to understand the question, look at the wine or the book, and then answer the corresponding question. As shown in the bottom image, existing work models the interaction among question, visual objects, and the test. The most recent work is using the transformers to do that. However, they tend to use the single question-answer pair for each input data during the training process because of the dataset being biased annotated. For example, on the bottom, given the input image with plenty of visual objects and OCR information, the existing model first extracts all the objects and OCR tokens, and then only uses a single question and answer pair to train the whole model. In this case, the question used to train the model is that, quote, what is the company name to the left of the course logo? And the corresponding answer is Safeway. However, as you can see, most of the OCR words and the visual objects are not fully used, and it is a waste of information. One natural question is that, can we further exploit or take advantage of those useful information and do something better? The goal here is that we would like to come up with a method to generate multiple meaningful QA pairs, such that we are able to use all those useful visual and test information to train the whole model to improve the performance. Specifically, with the same input image, we would like our model to generate multiple question-answer pairs from the existing detected OCR and objects without additional annotation efforts. For example, the augmented question 1 is, what is the company name below the clock? And the answer is Course Light. Here are the contributions of our work. First, we analyze issues of current test VQA models due to biases of data annotation and propose possible solutions to mitigate the issues. Second, our work is the first architecture to explore new question-answer pairs generation for test VQA task without additional annotated data. Third, we present consistently accurate results across two vanilla test VQA methods on two different datasets. The experimental results suggest that the existing test VQA algorithms can benefit from the high quality and diverse question-answer pairs generated. Let's talk about the motivation. We first do an easy math. On the left, it is the statistic of the numbers of annotated QA pairs and the syntax words for each image in the test VQA training set. Obviously, the syntax words are not fully leveraged in the annotations. On the right, it is a visualization example of a training image with more than 5 syntax words, which is typical in the dataset. Here is the architecture of our approach tag. Again, our goal here is to augment the original dataset by generating meaningful QA pairs, because a larger dataset always leads to a better performance. Tag is based on a multimodal transformer architecture, which takes a single image and test words as input and outputs a newly generated question corresponding to the input answer. The generated QA pairs from tag together with the originally labeled data are subsequently used to train test VQA models, leading to better test VQA performance. Specifically, During the training stage on the left, we use the ground truth QA pairs to train the model. We expect that the generated output question to match with the ground truth question. For example, the annotated question is, what does the ad on the left of the Coca-Cola say? And the annotated answer is firefighters. During the inference stage on the right, we use the test words detected as input and generated the augmented dataset. For example, the test word we choose is Coca-Cola, and the generated question is, what brand is the soda? Here are some visualization of the generated QA pairs. The top blue ones are the ground truth, the annotated QA pairs, while the bottom orange ones are the generated QA pairs by our tag module. On the left, given a word, SIGN, and the input image, we can generate a question like, what is the name of this drink? And the corresponding ground truth question and answer are, what is the first ingredient listed, and water, respectively. As you can see, the generated QA pairs quite make sense, right? We conduct the experiments on two VQA datasets. Here is the result on the first test VQA dataset. In details, we augment the original dataset by 2 times, and we train the baseline with the augmented dataset. Here are some experimental results on the 2 common settings. On the top, with the original test VQA training dataset, the baseline can reach 44.5% and 49.9% on the validation set. On the other hand, with the augmented dataset and the same model, we can achieve 45.7% and 52.5%. That is around 1.1% and 2.6% increase compared with the baseline. We further conduct experiments on another popular dataset, SDVQA. We could achieve a better results here as well. On the top of the table with the original SDVQA training dataset, the SOTA baseline tab can reach 45.29% on the validation set. On the other hand, with the augmented dataset and the same model, we can achieve 50.18%. In addition, the SOTA baseline tab achieves 50.83% and 0.598 in terms of the accuracy and ANLS score on the validation set with additional test VQA and 1.4 million large-scale pre-training data, while our model tag improves these results by a significant 2.7% and 0.022 with only additional test VQA data. We also conduct different ablation studies to demonstrate the effectiveness of tag using tab under the constraint settings on the test VQA validation set. First, as we can see on the top table, each input modality matters. Second, we think that the largest OCR box normally encodes the most contextual information, and that is why it's emphasized as a large box. Also, that is the setting in our previous experiments. We choose different answer selection strategies here, like random test word or top 3 test words, and the corresponding results are in the table. So again, TAG is the first genetic test-aware question-answer generation approach for the task of test-related VQA. Here is the summary. First, we analyze issues of current test VQA models due to the biases of the data annotation. Second, TAG is the first architecture to explore new question-answer pairs generation for test VQA task without additional annotated data. Third, we achieve consistently accurate results across 2 vanilla test VQA methods on 2 different datasets. Thanks for your listening, and here is the QR code of our implementation. Welcome to our poster to ask questions.